All right, guys. Welcome to Module 8 SMAW Electrodes. All right. Upon completion of this module, you'll be able to identify factors that affect electrode selection, explain the American Welding Society and the American Society of Mechanical Engineers filler metal classification system, identify different types of filler metals, explain the storage and control of filler metals, explain filler metal traceability requirements and how to use acceptable code requirements or applicable code requirements, and identify and select proper electrode for an identified weld. Okay. The powder metal adds filler metal and helps to improve the appearance of the weld. And when we're talking about powdered metal, if we look at the figure here, there can be powdered metal contained in the flux coating. So what you're seeing here is you have a stick electrode, metal core is being melted by the arc, and that's what's actually forming the weld bead, the mix of that core wire along with your base metal. And then there also could be powdered metals in the flux coating that add to the alloy that's created by the weld, by the electrode. Okay. Shielded metal arc welding cannot take place without electrodes. SMAW has often been referred to as stick welding, and the electrodes have been referred to as stick electrodes. The welder must be able to distinguish between different types of electrodes and select the correct electrode for the job. The arc at the end of the electrode melts the metal core, the flux coating, and the base metal at a temperature exceeding 6,000 degrees Fahrenheit. The wire core mixes with the base metal, forming the weld. As the flux coating is melted, it does the following. It gives off gaseous shields of carbon dioxide that protects the molten weld by pushing away harmful oxygen and hydrogen present in the atmosphere. Acts as a fluxing agent to clean and deoxidize the molten metal, and it stabilizes the arc and reduces splatter. It also forms a slag covering over the weld to further protect it from the atmosphere and slow the cooling rate. The most common electrodes are discussed in A5.1 and A5.5 specification. Those are AWS specifications that the electrodes fall under. Okay, here's a few different electrodes shown here. If we, top to bottom, we've got some 7018. There's a stainless electrode there, 6011, 6013, another different stainless electrode, some 6013, a couple different pieces of 6010, some 7014, and then we've got some 8010 pipeline or 8P plus. Just some different electrodes shown, and the numbers are important. We'll get into that. Okay, and when we look at the numbers on an electrode, so the E at the beginning signifies that it's an electrode. Okay, that means that electricity is passed through it and the arc is created at the end. This is in this process in SMAW, it's a consumable electrode, which means it's consumed as you weld. The first two numbers or three numbers following the E, if it's a 5-number electrode number, it's going to be the first 3. 4-number, it's going to be the first 2. That's the tensile strength in tens of thousands of pounds. So the 70 listed there would actually be 70,000 pounds of tensile strength. And tensile strength is just how much load the weld can sustain when it's being pulled. 1 is the weld position. That just signifies which positions the electrode can be used in. And then 8 has to do with the flux type and the current. Okay, so here's a list of common suffixes for or common numbering for electrodes. If it ends in a 10 or a 20, the flux coating is cellulose sodium. It's going to be DC electrode positive. Position, this is where it gets important. If there's a 1 there in that 3rd or 4th digit, that 1 signifies that electrode can be used in all positions: flat, horizontal, vertical, and overhead. When we have a 2 there, So if you notice there in that first one, there's a EXX20. It's only flat and a horizontal fillet. Okay, as well as we go down a few more, there's an EXX24. There's an electrode 7024 that some of you guys may have welded with. Sometimes it's referred to as jet rod, and it's a flat and horizontal fillet only. Very, very high deposition rate, puts down a lot of weld really fast. Okay, here's just an example of another electrode, E8018. Okay, manufacturer's classifications. All electrodes used for code work have the AWS classification number printed on them, as well as on the container in which they are supplied. In addition, electrode manufacturers print their own unique classification name or number on the electrode and or on the container in which the electrodes are shipped. So if we look at 6010, 6010 that's manufactured by Lincoln will be referred to as 5P or 5P plus. Their 7018 electrode, they call it Excalibur. Same thing, just kind of trade names. Okay, now we're looking at numbers to the right of the electrode number. We've got E8018-C3. C is going to be the chemical composition or alloy, and 3 is the composition of the alloy. So what alloy is it? So here's some different listings based on different alloy types. All right, this is what I was talking about here. So it's just showing different names for different electrodes. You know, look at an E6010. Hobart calls it a Pipe Master 60. Airco calls it Pipe Craft. ESAB, it's AP100, SW610, or SW10P. And then Lincoln, like I said, Fleetwood 5P or 5P plus. McKay, it's just 6010M. You know, we look at E6011, again, the same thing. Different classifications, 6013 as well. 7014 and 7018 also. Just trade names that they have, although they fall under the same classifications. Okay, and here's just some different types of containers. A lot of what we purchase in 50-pound cans, just because of the amount of electrode we go through. But occasionally we'll purchase 10-pound cans of other things. Like I have a small can of stainless steel electrode in the shop that was purchased in a 10-pound can. So we don't use a lot of it. 1-pound boxes, there's really not enough there to do much with unless you're a hobbyist. So just multiple packaging options. Okay, number of electrodes per pound. So if we look here, 1/8-inch electrode, 6010, looks like it's somewhere around, 15 to 7, well, it says 17 electrodes per pound. So in our 50-pound cases, we've got somewhere around 530 electrode or something. So in that 50 pounds, or I guess 800, about 850 pounds of, or 850 electrodes in that 50 pounds. So quite a few electrodes in there. Okay, looking at suffixes here. We'll look over these numbers here in just a minute. I know on Excalibur H4R, for the suffix, that is actually denotes how much hydrogen content is in the flux. Okay, this is a picture of a rod oven. This one's a little bigger than the one that we have in the shop. You can see they have multiple cans and sizes of cans and multiple, looks like sizes of electrodes as well inside the oven. All right, here's just some selection factors. When we look at electrodes, these are common steel electrodes and their selection factors. We have 6011. It's an AC or a DC electrode positive polarity. It's good for dirty, rusty steel. 6013, good for thin steel and poor fit up. 7014 is good for thin steel. 7018, good for high deposition, good for medium or high carbon steels. You know, so this is just kind of some different uses. You know, if you work in the ag industry much, you know, you're really going to run across a lot of 6010 or 6011 and 7018. You'll do a lot of repair work with 6010, especially in the dairy and beef cattle industries. A lot of pipe fences built using 6010 and 6011 electrode. A base metal. The chemical composition and mechanical properties of the base metal can be obtained by referring to the base metal mill specifications. Normally an electrode that is smaller in diameter than the thickness of the metal to be welded is used. So if you look, we're practicing on, you know, roughly 3/8 plate, and we're using either 1/8 inch or 3/32 inch electrode. Okay, low hydrogen electrodes. So this is looking at exposure time. This is really important. This is when you're doing code work with 7018, the electrode has to be stored in an oven where it can be kept dry. If we look here, it's showing the maximum exposure before they're re-dried. So if the rod is out in the atmosphere for too long, it has to be re-dried or rebaked. This differs a little bit with every welding code. You know, refer to your code or refer to the inspector to manage this. There are some industries I have heard that PG&E at times, once a can's open and it passes the amount of hours that they limit, then the rod's just thrown away. They don't mess with rebaking, partially for liability and safety. Code requirements. Welding codes require electrodes with a low hydrogen coating to receive special handling. They must be shipped in hermetically sealed containers, and immediately after opening the sealed container, low hydrogen electrodes must be stored in special ovens at a temperature of 250 degrees Fahrenheit. Electrodes can be used if the coatings are not damaged and they have not come into direct contact with water or oil. Mark electrodes that cannot be used and notify your supervisor. Each container must be marked with ASME, AWS, or other electrode specification numbers and electrode classification designations, the electrode size, and the weight. Here's a couple of just different rod ovens. Exposure times. The time that low hydrogen stainless steel or nickel alloy electrodes can be exposed to the atmosphere is listed and depends on the electrode. If high moisture electrodes were used to make welds on critical equipment, the welds will have to be replaced. Drying electrodes. Electrodes that exceed the maximum exposure time can be dried once. Filler metal traceability requirements. One of the more common requirements followed may be found in the ASME Boiler and Pressure Vessel Code, Section 2, Material Specifications. The section of the ASME code lists applicable base metals and filler metal combinations. And that concludes the PowerPoint. Hey guys, don't forget to complete the quiz and the discussion post and prep for the test. Have a good night.